இங்க வருமா? இது மேல வருமா? Get started. So what was the last topic you saw? Power of lens. So any doubt till whatever we discussed? Is everything clear? You understood the logic behind all the derivations, right? Okay, then we'll start with the next part. So write down the next heading as effective power of lens. Effective power of lens in contact. So if two lenses are kept in contact, what is going to be the effective power? Okay. Device itself is slow today. Sir, online, are you able to hear me? And
yes, sir.
yes, sir. Okay, we'll see. So write down the heading as effective power of lens in contact with each other. Means if two lenses are in contact with each other, what would be the effective focal length? Right? So let's say there is one lens like this. See, it is not necessary that both the lenses are supposed to be concave or convex altogether. They can be a combination also. But if those two lenses are in contact with each other, let's say the focal length of the individual lenses are f1 and f2. Okay. Then, what does lens formula tell us? What is lens formula? Yesterday we derived it. 1 by v minus is equal to 1 by f, correct? By f, okay. So 1 by v minus 1 by u is 1 by f. Okay. Speed 60 hertz speed la poitu irukka. What do I do? I think it's fine now. Yeah, 1 by v minus 1 by u is 1 by f. So for lens 1, if you apply 1 by v1 minus 1 by u1 is 1 by f1, correct? Can you see that? Similarly, for the second lens, okay, so logic work, observe the logic. If I keep an object here, okay, let's say at point O, which is at a distance of u, and the final image is formed at this on the right hand side. Now, what will happen in this kind of a scenario is, whenever you have multiple refractions happening, okay, have this in your mind. Whenever there is a concept of multiple refractions, the refraction due to the first object will produce an image. Correct? So refraction due to the first object will produce an image, and that image will act as the object for the second lens. So if 1 by V1 minus 1 by U1 is 1 by F1, right? This V1 will become the image distance for whom? For the second lens. So image distance, it will become the object distance. I'm sorry. So 1 by, let's say the 5 image. 1 minute. I don't think you'll have a problem. So 1 by V minus 1 by second lens, what will be the object distance? This is what I told you. U1 V1 will start acting as C. So image distance of the first object or due to the first lens will start acting as the object distance for the second lens. So 1 by V2 is equal to 1 by F2. If you observe one point here, I didn't apply sign convention, did I? Why? Sign convention. I'll try to keep it there and see, but you will not tell me. Guys, is it okay if I'm not visible? Okay, that's okay. We are happy to see. Now I think it should not be a problem. So 1 by V minus 1 by V2 is 1 by F. Yeah. So why did we not apply sign convention here? I told you, right, from the beginning, I've been telling you wherever needed. For every derivation, you need to apply sign convention. But if you're solving also, you need to apply. Yeah, tell me.
So you said that the image of the first one would be the object for the second one. So why is it not 1 by V1? So why is it not 1 by V1?
No, V1 only, I'm sorry.
Oh, okay.
That's right. So I had V1 in mind, but I wrote V2. Okay. So one, but if you see, I didn't apply sign. So V1 I don't know where it is from. Now, what did I tell you in this particular exercise? What did I tell you? There is an object which is kept at a distance of U. And what are the kind of lens I considered in this scenario? I considered a convex lens. If a convex lens, if you take the ray diagrams, how many ray diagrams are possible with respect to convex lens? 5 or 6. Simple, come from the extreme point. One infinity, one beyond C, at C, between C and F, at F, between F and O. So 1, 2, 3, 4, 5, 6 RL. So what happens in this scenario is you need to make a note of it. In the first 5 scenarios, the image formed will be a real object, will be a real image. Whereas convex lens has a special type of property. It is the only lens which can produce a virtual and magnified image, because concave lens is the thing which, if you take concave lens, how many ray diagrams are possible? It is only 2. One is at infinity, one is beyond the, one is on any side of the mirror. Lens. Now, what will happen is you will have virtual image only, but they are diminished. So if there is a possibility where a virtual image is magnified, where is it possible? Only for convex lens. The challenge is, when I say the object distance is U, I have 6 different scenarios for this case. So I am not sure whether I'm going to have a real image or a virtual image unless and until I know where the object is exactly placed. So my object distance itself is unknown here. So from the beginning, I've been telling one thing. What is it? Which values will you apply sign convention? Only 2 values which are known. If you go through the other derivations, okay. So I'm stressing on this point because you should not get confused. You should not get that question. Right. So if you see in all the other scenarios, we have drawn the exact ray diagrams. So we know where the image is formed and where the object is placed. So that is why we went with the concept of sign convention. Whereas in this scenario, this is only an approximate scenario. I don't know where the image V1 is formed. Another, I have no option other than going without applying sign convention, because everything is unknown except F1 and F2. Not necessary. Not necessary. It's up to me, right? Okay. Upper 6 case எடுத்து நீ பண்ணணும், which will be tedious. You want to remember 6 different formulae? 6 case would 6 case. It is there, but you will have multiple scenarios, right? In the concept another. What are you even trying to do? Heading per or effective power conductor of lens in contact. I have taken only 2 lenses. Is it necessary only 2 lenses will be in contact? I can have 3 also. So you எடுக்கும்போது எத்தனை combination வரும் பாரு? Multiple போகுமா? It is difficult for us to sit and derive for everything. So it is always better we have a generalized formula. And the generalized formula and using the lens formula to see, correct? So இப்போ என்ன பண்ணனும்னா, you need to add these 2 values. When you do that, you will get 1 by v minus 1 by v will cancel out, but yeah. Is it getting cancelled? So 1 by v minus 1 by u1, or u1 வந்து actually u தான், if you observe. Guys, am I clear with that? So 1 by v minus 1 by u is what? Is 1 by f. Sorry, 1 by f1 plus 1 by f2. See, if you see 1 by v is there, no? V is the final image formed due to the system. U is the object distance with respect to the same system. So 1 by v minus 1 by u is 1 by f1 plus 1 by f2. Clear? So what I can say is, this 1 by v minus 1 by u, I'll call it as 1 by f effective, which will be equal to 1 by f1 plus 1 by v is the image formed after multiple refractions. U is the initial object. So like this, if you keep 3 more lenses in contact, what will happen? You will have v1, v2, v3, v4. But adellame nullified. Adellame cancel it. End value you will only have 1 by v minus 1 by u as 1 by f1 plus 1 by f2. So that's what happens. And this 1 by f effective, what is the meaning of f effective? Meaning, if I have multiple lenses in my hand, I can replace all those lenses with one lens, which can do the same work done by the combination. So this is the same thing, like how you find the effective resistance or equivalent resistance, the same logic. So from this, I can conclude that effective power is equal to P1 plus P2. Am I clear with this, guys? So make a note of this. Same size, no? Same size of the object is? I have to check. I think it is possible. I never thought of it, but yeah, it should be possible. The problem is that I can solve it. Why I am saying it could be possible because that depends on where you place your part. That is important. Okay, shall I proceed? So here I want you to make a note that when you are applying this formula, you need to apply the sign convention. So 1 by f effective is equal to 1 by f1 plus 1 by f2. So power effective is equal to P1 plus P2. But when you apply this formula, you should apply sign convention. Minus plus. Focal length of the convex lens is positive. A point mentioned by the right. So I hope everybody wrote this point that when you're applying the formula, when you're applying this formula and when you're applying this formula, you need to apply sign convention. Okay. And the sign conventions are like this. Focal length of a convex lens is positive. Why is it so? Because generally, as you told, you will always keep the object on the left hand side. When you when will you even think of focus? How is focus defined as? It is a point where the image is formed for the object kept at infinity. So when you take it like this, so it is forming on the right hand side. Another focal length of a convex lens is always positive. Whereas when you take for the concave lens, when you take the ray like this, it gets diverged. So where is the image formed? On the left hand side. So focal length of a concave lens is negative. Any doubts? Is it clear? Shall I proceed? Okay. So this is all about lens, and one last concept that is left out is lens makers factor. I was telling you about this, no? Lens makers factor. Just give me a minute. I need to open the file. So write down the heading as refraction by a lens. So here you need to understand one point. Okay? So what do I mean by refraction by a lens? First of all, how did I define lens as? Lens is an optical device. And what does it mean? Where at least one of the refracting surfaces is spherical in nature. That's when you call it as a spherical lens. If a refraction by lens, now what am I trying to say? So lens, how many surfaces do you have? Minimum is two, minimum, maximum two. So one day we not call it as a lens, it's just a boundary. Another, we learned a concept also. You see, refraction at spherical surface. The refraction at spherical surface variable. So the boundary, it's a surface which is dividing two different media. But again, the topic refraction by a lens means I need to speak about two refractions. After undergoing multiple refractions, where is the image formed? So again, when I talk about refraction by a lens, how many types of combination can I do? How many types of lens can I give you? Then, I gave a biconvex, biconcave, plano-concave, plano-convex, concave or concave, convex or concave. So it's a combination. But all these lenses have two surfaces. All these lenses have two surfaces. If I have to analyze the individual situation, I need to dissect 6 different combinations and understand. It is again a tedious process. Instead, what we will do is we will take one particular scenario into consideration, dissect it into 2 parts, right? We will see. So the logic is again simple. Wherever multiple refractions are undergone, what is the logic I told you? Image formed due to the first surface will always act as the object for the second surface. This is the logic. Just if you see any refraction, glass slab level. Glass slab level, how many refracting surfaces did you have? So this is the incident ray, refracted ray. The refracted ray started behaving like an incident ray for the second same logic. Except the fact that here it is planar boundary, இங்க வந்து curved boundary அவ்வளவுதான். சரியா? So அப்படி இருக்கும்போது we will see how does it look. So for you to understand and apply this concept, one prerequisite is you need to know the concept of refraction of lens. Refraction of lens formula என்ன? ஒரு வாட்டி பாத்துக்கோங்க. mu2 by mu2 by v minus u1 by u is equal to u2 by v minus v1 by u is equal to u2 minus v1 divided by r. Right. So, what is mu2? See, actually, people making mistake here. mu2 refractive index of what? Second and another. It is not second surface. Look at the denominator. mu2 is a refractive. Just because you have a 2, it doesn't mean it's second surface. It is the refractive index of the surface where the image is formed. mu1 by u another. Refractive index of the surface where the object is placed. mu2 minus mu1 by r. R is a boundary. So radius of curvature. Depending on how the surface is looking, you can find the radius of curvature. Am I clear to this point? Shall I proceed? Listen. Suppose, guys, those who are online, I hope you're able to understand, right?
Yes, sir.
Good. So, as I told you, you have multiple scenarios out of which we have taken the example of a biconvex lens. You can take concave lens, you can derive to this something. Okay. But I'm just going to the text. So, what did I tell you? What is the logic and how are you supposed to think? You have two surfaces, not dissect. So, first surface is what? So, if you break it into two equal parts vertically, correct? If you break it vertically, then what happens? You have one curved surface on the left hand side. And where is it? This is the curved surface AC. Am I clear till this point? Suppose I place a point object at a distance u from the optical center. Again, here, what is the data we don't have in our hand? U is okay, but I don't know where exactly it is placed. I don't know what kind of an image is going to be formed. So we only go with the rough estimation. But I know I have one data in my hand. That is this boundary AC, which is in the form of a C, right, is actually separating which two media? It is separating a media whose refractive index outside is mu1 and inside medium as mu2, where mu2 is the refractive index of the lens material that you are using. This is the tricky part you need to understand. I repeat it again, listen. So C shape on the left of C, what you have, you place an object. Right? And the object placed in a medium, I'm calling the refractive index of that medium as mu1. I don't know where the image is formed. I don't know whether the image is formed on the same side or on the other side. But I'm clear with the fact that the boundary is separating mu1 on the left hand side and mu2 on the right hand side. mu2 another. What is mu2? The refractive index of the material with which the lens is made of. Not necessarily it needs to be glass always. How many of you are wearing glass spectacles, sir? Because it's glass, sir. I've thrown many fiber. I'm going to go on the first part. Okay. So refractive index of the lens, yours, fiber. Okay, refractive index of the lens. Nobody is using glass. Okay. Similarly, when you place this object, right? If I have to draw a ray diagram, yesterday I gave you a practice if you remember. Right. So when you do that, let's say this is the incident ray. Okay, you're hitting the point. Let's say at N1. So yeah, at the point of incidence, always draw the normal. For a spherical surface, normal always. We can assume that. Mostly you will be in the rarer medium and will be in the denser. See, if you take the real time scenario, specs photo. So I am in which medium? This side is what? It is rarer. Generally, we do. I will not immerse myself into water and then try to do this experiment. I will normally do it in a lab, right? So generally, outside medium is considered to be rarer, and the lens material is considered to be denser. So this is going to be the normal, correct? So this is the angle of incidence, I1. Then what will happen when the ray is starting from rarer to denser? What happens? It bends dash the normal towards the normal, right? So it bends towards the normal, and when it is bending towards the normal, this is one of the refracted rays, and obviously the other refracted ray we will consider along the principal axis itself. So this is forming an image at which point? At a point I1 in the second medium. Where is it forming? It is forming in the second medium. Okay. So they have given no N1 and N2. In your textbook, they use N1 and N2 for N for refractive. That's the only difference. And let's say the radius of curvature of the first surface is R1. Is there anyone having confusion? I1. It forms as the object for the second surface. I just wanted to stress on one point. Okay. Listen to this. Suppose the same boundary is there. You listen, you need not draw, but think about it. If this is O, if this is the point of incidence, I'm drawing the normal. This is the actual one. Correct? When I say bending towards the normal, why are we always drawing more towards the normal? Why can't it bend towards the incident ray itself? Why can't it be close to the principal, close to the incident ray? Meaning, if I draw this as the reference line, I drew a third line, right? At the point of incidence, the concurrent line. So for that line, if the ray is getting bent below that line, then you will get this kind of an image. Correct? But why can't it bend like this also? When it bends, the image would have formed here. It could have happened also, and it can happen. If this is a possible scenario. So that is why I told you at the beginning of the concept itself that this is only an approximate diagram. So for an approximate diagram, what I'm supposed to be do with sign convention? Do we need to apply it or do we not? We need not apply. You should not apply. Now you understood why you cannot apply for this scenario? Okay. I hope those who are online are also clear.
Yes, sir. Yes, sir.
Good. So this image I1, where is it formed? That image I1 is actually formed in which media? Sorry, which medium? It is actually formed in the second medium. To be honest, the image will not be formed at all. What we are trying to say is, if the second refracting surface was not there, then this would have been the point where this image would have been formed. It will not form. If it forms, right, you will be able to see two objects when you look through your lens. Okay, this is an intermediate step, and this image I1 starts acting as the object for whom? For the second refracting surface, which is looking in the form of an inverted C. Inverted C. Then, so what I'm trying to say is, if this is the boundary, the ray has come here. Inside the lens, it has got bent to an extent that if the second surface was not there, my image would have actually formed at this point. But since second surface is also there, it is undergoing one more refraction. It is undergoing one more refraction so that This is where I am able to see the final image of the object that I get. So, concentrate. So, inga bend avudra. Okay. In the second surface, had it not existed, this ray would have traveled undisturbed. Nobody is there to disturb it. But what is happening? The bent ray is going and hitting the second refracting surface. When it is hitting the second refracting surface, it is getting bent even more, depending on the scenario only again, depending on the refractive indices of the materials. So one thing that is common here is refractive index of the lens is constant, and on either side of the lens, it is not like this side refractive index is mu1, here it is mu2, and here it is mu3. On either side of the lens, it is mu1 only, and the material of the lens is mu2. Are you able to understand? So what is happening is, did you get the justification for this diagram? Did you understand how it is actually? It is because of the second refraction that the ray is undergoing. And I repeat it again, this is only an approximate. So, third diagram. Am I clear? Right? So our job is to find what would be the focal length of this particular lens in terms of refractive index of the material. So if you observe,
Sir, in third diagram, it is the rays moving from denser to rarer, sir.
It is denser to rarer.
Okay.
Okay, that is why it is bending away from the norm.
Yes, sir.
So here another point to be noted is in this diagram, the radius of curvature of the first surface is alpha, the radius of curvature of the second surface is alpha. So, but both these surfaces are individually called as spherical surfaces. So, can I apply the formula? Can I apply the formula? So for the first surface, for the first surface, can I say mu2 by v1, right? Minus mu1 by u is equal to mu2 minus mu1 divided by r1. Can I say this? Is there any doubt? Observe the expression and let me know. mu2 by v1 minus mu1 by u is equal to mu2 minus mu1 divided by r1. Similarly, for this,
the second, how did it go basis?
Generally, it is measured from the principal axis. This is the principal axis. So what is this point called as? On the refracting surface, you can call it as a pole. So, in two terms, pole only for surface. Another mirror is a surface. Mirror is not like two sides. Whereas optical center is used for lens. So, the pole on the left of it will be the radius of curvature. Basically, logically simple. This sphere convert this will be the radius of curvature. The sphere would have part than other. Right. So for the second part, this is where you need to be careful. How do we apply the same refraction at spherical surface for second part? Where is the final image formed? mu1 by, because images will definitely not be formed within the lens for sure. Either in the side or in the side, but definitely it is a medium one. mu2 by mu1 by, we'll take it as v, because that is where the final image is formed. Minus mu2 is where the image into the first refracting surface is formed, which is acting as the object for the second one. So mu2 by v1 will be equal to. This is where you need to be careful. It is mu1 minus mu2 divided by r2. Correct, then. It is mu1 minus mu2 divided by r2. Right, these two are the two crucial steps. See, in terms of mathematical part, it is easy only, but logic is more important. Purida, any doubt in this? Clear? So what are you supposed to do? Add this. When I add both the equations, I'll get mu1 by v minus mu1 by u is equal to mu2 minus mu1 into, can I write it as 1 by r1 minus 1 by r2? Observe. Because mu1 minus mu2 I can write it as minus of mu2 minus mu1. So add them, you will get this. So what is common on the left hand side? Mu1 into 1 by v minus 1 by u is equal to mu2 minus mu1 into 1 by r1 minus 1 by r2. So what is 1 by v minus 1 by u? 1 by f. Mu1 divided by f is equal to mu2 minus mu1 into 1 by r1 minus 1 by r2. So what will 1 by f be equal to? Okay. The equation. I am saying mathematically rearrange panna enna varum. So you will get 1 by f is equal to mu2 minus mu1 divided by mu1 into 1 by r1 minus 1 by r2. Can I write it in this way? So, like how we told, 1 by f can also be power. 1 by f is power. That's what we got. Tell me. But there is a minus sign. Look at the expressions. Which terms are getting cancelled? Got it? You want to breathe it? Clear? Wait it. See, this is mu2 minus mu1. Together, mu2 minus 1 here. mu2 minus 1, 1 minus 2. So take the minus at the minus of 2 minus 1. Correct? So mu2 minus mu1 into mu2 minus mu1. But 1 by r1 is minus 1 by r2. So I'll add that's minus 1 by r2. Simple. Step I'll write it and show. mu2 minus mu1 divided by r1 plus mu1 minus mu2 divided by r2. So it is mu2 minus mu1 divided by r1. In case minus minus mu2 minus mu1 divided by r2. So what is common in the numerator? Numerator. Mu2 minus mu1 is common. Into what in the r1 1 by r1 minus 1 by r. Direct. This is a very, very important expression. If there is any doubt, please get it clarified. Very, very, very important. Is there any doubt? So to be more specific, this is how the formula is written. It is not written as mu2 minus mu1 by mu1. It is written as mu2 by mu1 minus 1 into 1 by r1 minus 1 by r2. There is a special name for this formula. Though we started with the concept called as refraction by lens, this formula is called as lens maker's formula. So why is it called lens maker's formula? You try to understand. Go to an optical shop. See, first thing, what will they do? If you get a headache, you want to go for night check. What do they check actually? Power, right? Power is a reciprocal of focal length. So depending on the power, what will happen? They will design a lens for your eyes. So is every lens of the same, is going to be of the same curvature? Another I asked you in the beginning. If you have a glass, the curvature if you have a fiber, its curvature will be different. Because the refractive index of those materials will change. So they are trying to say this equation tries to tell you that the lens that we need to prepare depends on the refractive indices of the medium in which that lens is going to be present. And it depends on the radius of curvature as well. That is decided by the power of your lens, power of your eyes. Guys, those who are online, are you clear?
Yes, sir.
Yes, sir.
Yes, sir.
Okay. See, suppose let's see the application part of it. Suppose I have a biconvex lens like this, okay, and the refractive index of this material is mu, okay, and I'm saying it is equiconvex lens. What do I mean by equiconvex? More important. More than focal length, can you? I know focal length and the other term. You more speak about radius of curvature.
Aperture will be.
Radius of curvature will be the same. Yeah, of course, focal length also will be the same. That's a different story. But mostly when they say equiconvex, what will you say? Radius of curvature is the same. So, right. Now, though we derived, see, if you observe this derivation also, we never applied sign convention. But when you solve the problem, you need to apply sign convention and a general formula. Right? I am trying to find the focal length of this material in terms of its refractive index. So let's say the radius of curvature of both the sides is capital R. Okay. Derive the focal length value and tell me. So since I told you it is equiconvex lens, radius of curvature of both the sides is capital R. Focal length. Normally, what is the relation between focal length and radius of curvature? F is equal to R by 2. Answer R by 2 is R. You will not get it. Because F is equal to R by 2 is applicable only for a thin lens. So when you are applying the lens maker's formula and everything, you are applying it for thin lens. What do I mean by thin lens? The thickness of the lens is very, very, very small. Okay. Whereas here, it need not be a thin lens. If a radius of curvature, if I take it to be R, 1 by F, 1 by F is equal to mu2 divided by mu1 minus 1 into 1 by R1 minus 1 by R2. 1 by F is equal to, what is mu2? mu2 is the refractive index of the material. Which material? Of the lens material. It is mu divided by mu1 is how much? It's the outside medium's refractive index. 1 minus 1 into 1 divided by R minus 1 by R. What will the answer be? This will be 0. So focal length will be infinity. Correct? Correct? Biggest blunder you can ever commit. What did I tell you? Thin thin lens infinity ada sonna focal length idu illada, don't get confused. F is equal to r by 2 is applicable only for thin lens. Somebody use that. If we apply sign convention, need to apply sign. Purida, I know first I've seen many mistakes of this sort. First thing they will do is that they write this infinity and be so confident. Because for the first lens, for the first curvature, radius of curvature is positive. Whereas for the second surface, radius of curvature is negative. So what are we supposed to do? Minus line or minus 4. So this is wrong. And the right way to write it is 1 by f is equal to mu minus 1 into 2 divided by r. F is equal to r divided by 2 into mu minus 1. This is the right refractive index. Is it clear? Okay. Next is, as I told you, this formula is important. I will give you some more tips on this. Okay. I hope everybody copied this. You copied it. Sign convention. Arindra. Shall I proceed? Listen. Let us say this concept is very important. Listen. Let us say I have a lens whose refractive index is 1.5, okay, which is made of glass, and it is placed in a medium whose refractive index is 1.75. What are we doing? You're taking the lens and putting it in a denser medium. If you do this, then 1 by f will be equal to mu 2 by mu 1 minus 1. Mu 2 euro 1.5 divided by 1.75 minus 1 into, let me call this as equiconvex. Equiconvex, just now we saw, what do I get? 2 by r, or next time onwards you can remember this. 1 by r1 minus 1 by r2 will be 2 by r. Breathe. Now listen. This value, what will happen? 1.5 by 1.75, is it a value greater than 1 or less than 1? Less than 1. So less than 1, if you subtract 1, you will get a negative value or a positive value. So 1 by f, I'm not calculating, but sure I know that it becomes negative. Now listen to this point. Actually, what lens did I give you in the diagram? Convex lens. So for a convex lens, what did I tell you is the sign convention of a focal length is possible. But you took that convex lens and you dropped it into a medium of greater refractive index. Its focal length has become negative. So this is a very, very, very important point. Whenever you take a material, right? Whenever you take a lens material and drop it into a medium of greater refractive index, what you're doing? When you drop it into a medium of greater refractive index, nature of the lens will change. Means convex lens will start behaving like a concave lens, and the concave will start behaving like a convex lens. Is the point clear? So this is actually the first property of lens makers formula, right away. So what is it? If a lens of given refractive index is dropped into a medium of greater refractive index. Write it down. If a lens of given refractive index is dropped into a medium of greater refractive index, nature of the lens will change. Nature of the lens will change. Okay. Freedom. So why? You have the formula. So that's what lens makers formula tells you. So below that point, you can note down this equation.
Sir,
Tell me that.
what is after greater refractive index?
What if it is?
What is after greater refractive index to a medium of greater refractive index?
When you drop it in a medium of greater refractive index, comma, nature of lens will change. Nature of lens will change. புரியுதாடா? Okay. So this is all for the day. In the next class, I'll explain you about. I'll do some problem based on. As I told you, this is very important topic. So revise it and come. Next class on Monday. First 15 minutes, you have to write down all the derivations that we discussed. We discussed 2 derivations. No? I want you to not even to lens makers formula write it. That's it. Okay, on Monday you have to. First 15 minutes, there will be a test on the lens makers formula derivation. Solra, Nitish.
Sir, nu 2 by nu 1, right, sir? In lens maker's formula.
Amanda, mu2 is another. mu2 is the refractive index of. mu2 is the refractive index of. Second, first, ஞாபகம் வச்சுக்காதீங்க. mu2 is the refractive index of. இல்ல. எதுல lens makers formula இல்லையா? Lens makers formula image formula கிடையாது. mu2 is the refractive index of the material with which lens is made. mu2 is the refractive index of the material of the lens, and mu1 is the refractive index of the outside medium.
Okay, sir.
Okay. Seriya?
Yes,
So that's it. Any other doubts, sir? Any other doubts? That's it. Okay, then we'll wind up.